Hello folks, well, Wednesday, we've got a road trip today. Not sure whether, I think we've got an option of two things. One was around Buxton in Derbyshire, and I wouldn't mind popping in to see a certain person who fixes telly there, but I haven't heard from him, so we will probably do Grimsby. I think we've got to go to a church at Laceby Road. So, we'll call in at Cleethorpes, and you never know. Should have taken my Speedos. No. Might have done when I was 29. Right, this is a Rotel RVC220. The customer thinks it's been on a high SWR. I think he's had a high SWR. We've got a nice chip out of the front there. Is it a soldering iron chip? These, as we all know, are very good sets. Using the Cybernet 134 chassis from 1981. Plug it into the test gear, and without opening it up, I've asked him to send a power lead in. I've asked him to send the mic in, but at this stage we're going to do it all on our test ones. The reason I asked for the power lead in this case is that if he doesn't think it's transmitting, or it's not transmitting sufficiently, there could of course be a resistive problem with the power lead, like a dirty fuse holder, so that the power lead is only letting like half an amp through or something like that. So that's why I would ask in that case. Also, if he's got no transmit, of course the microphone could be not sending it in to transmit. So we've got it on our standard replacement microphone, we've got it on our power lead, and at this stage we're going to... Was that Team ME4 yesterday? Ended up working quite well for a modern set. Right, so we're all ready. Supposed to be no TX. So we'll power it up. That stiffen needs dealing with. Imagine it's a bit skew whiff. It's possibly been bashed at some time in its life. There's an animal grease they use to make them stiff, and we need to kind of add some light oil to try and dissolve that a bit. A bit like record players with the auto return mechanisms on the BSRs and the Garrards, having to remove the grease and put something lighter there, so it's too stiff. Oh, and the squelch is just the same. It's probably been in a very damp environment, so put it on channel 20 and let's go into transmit. I'll switch picture in picture on, and there we are, and it's transmitting. So one of the things he said in his note to me was that because of what the meter said, he didn't think it was transmitting sufficiently. So right now the radio is beyond 3 watts, gone to the other scale. The radio is actually doing 3.1 watts at the moment, and it's reading just under 4 on the meter. So into a dummy load, so perfect SWR, the meter's calibrated correctly. So is transmitting. So it may well be a retune and test and not a repair. That would be nice for him cost-wise. Deviation, for what it's worth, wallow. Oh, we were on CPT yesterday. Wallow, wallow. Somebody says, why aren't I doing a direct inject of the signal audio generator into the microphone thing? And the answer to that is the different requirements. Most of them are 4 millivolts, but although that, you know, if you're doing, supposing you've got 100 sets all the same, absolutely, you know, you're going to do it that way. But the microphone you actually supplied with it, I was told was the correct thing. And I mean, you know, that's something we were doing at Nottingham Radio. It's something I was doing on the training courses with Maxon and with Tate and with Pi. So yeah, if you're batch doing it using the direct inject into the thing at a level that you've already determined by using the microphone, not necessarily what it says in the manual. So we're doing different sets every day, so we're not going to do it that way. So we know we've got, let's be kind and generous. It's doing 3.1 watt on channel 20. It's drawing 991 milliamp, which is correct. Low power, wherever the switch is. It's doing 140 milliwatts. So that it really is low. Sometimes the preset's dirty, sometimes it needs replacing. Deviation, wallow. I don't know what to believe on the test set. Wallow. It is 1.7. So we'll put that kind of in brackets. Frequency. Now, I'll tell you what, we'll do the other channels first. Channel 40. It's 2.9 watts. I lost my voice. And channel 1, 3.1 watt. So it's balanced how you'd expect it to be, and it's within 0.1. Frequency. Let's go over to the frequency counter. Test set's only been on for half an hour, so we'll kind of take it with a pinch of salt. We can always come back to it where we need to be on channel 20, really. 27.79125, 27.79083. So although it needs pulling up, it's not illegally off. It's hardly noticeable that it's off. Receive, so we're going to put in the same frequency, 27.79083, so we have an absolute fair test. So of course I don't know where the gentleman lives, I don't know what his aerial arrangement is, but with our aerial here towards Nottingham we can get 35 miles to our car, and in our worst direction we're going to get about 8 miles. We can't get to Colsterworth, which is 10 miles away, which is such a shame. If we go towards the Sleaford direction, which is where we do the scratchy corner test, it works on the way into Sleaford. For the actual town it drops off and then it comes out the other side. So we probably get about 14 miles in that direction. And then towards the north, we're okay towards Newark. In the town itself it would be no good at all. Come out the other side, and certainly over the River Trent towards Carlton-on-Trent. So we're getting like 21 miles, something like that. You can pick your spot up to 30 miles away in that direction. So that's what we get on a normal aerial with normal thin cable and with a 4 watt legal radio. 7912. I'm talking away, not doing my job. 79. So we've now got the signal generator as off frequency as the transmitter is, so it is a fair test. And we're hearing 1 microvolt. I'll plug it into the test gear, and that's the kind of level you'd expect. Let's go over to the synod meter and get some figures. I'll tell you what, folks, it's one of those better sets. 0.25. 0.21. I doubt we're going to get any improvement on this on receive. And 0.46. So the manufacturer says not better than 0.47. Sorry, says better than 0.7 for 12 dB. Well, we're well better than that, so it's one of these which works well. Squelch to full. And let's see where that is. I'd like it to be 100 microvolts for it to open. There's no hard and fast rule. It's pretty weak. It's too weak at 30 microvolts. So that does need addressing. Minimum, so threshold. It's coming in at 0.3. So it is quite a reasonably working set. It needs a service. It's 40 years old. And it's reading 3.8. Let's look at where the S meter is reading for receive. It's a bit lazy. It is 540 microvolts. Meter lamp works, switches work. These don't have PA. Right, that's a jolly good start. Let's open it up and we'll start with the VCO. So I think something to get across to the customer, to a lot of people, you will not get better performance on any radio you buy. This is one of those exceptional sets. It's not one of those sets you sell because you think you're going to get a better set, because there isn't a better set. You've already got the better set. If you think you want CPT channels, which you don't, then buy a set which does that by all means, but not to replace this, because you're not going to get better performance. I was wondering where the Pi Westminster service manual was. I was going to do the Pi Westminster today, and put it on handband by nicking the crystals, borrowing the crystals out of one of our other sets. To see if that one which was kindly sent in to us actually works. But this is a paid repair, so of course it's taking priority. We've got quite a lot of repairs coming in. That's why I wanted to get the Westminster out of the way. Just looking at the capacitors, I can't see any issues there. I've got the light. I thought there was a bulge in one down there, but it's the way the light was. There's no strap across there. It doesn't matter, but it makes it harder for me to put the test probes on. So, we want channel 1. We're looking for 4 volts. And we're looking at resistor 4 for that point, and as you can see, it isn't right. So 4 volts. This means you end up with channels dropping out in temperature extremes. We've all had the radios that don't work above channel 38 and work below channel 2. A bit like some new sets. Like the Midland 78, we had it before the Thunderpole 3000. Right, so we've got that exactly where we want it for receive. Oh, my negative's dropped off. That's what happens when you haven't got that earth strap. Transmit. is 5.4, so that needs to be altered. The red trimmer. I'm going to waggle that around because it can get dirt in them. So now our receive is 4.01 and our transmit is 4.05. We had something like 2.8 plus 5.4 before. Now we've got 4 plus 4, which is where it should be. So that was really worthwhile doing on this particular set. This could be some of his transmit issues if he's been on those extreme channels and it was playing up on channel 140, for example, because that was really going to be on the verge of whether it was going to transmit or not. Right, so we're back on channel 20, and we need to select the main meter on the test set and see whether we can get these sets. Are supposed to be able to do 3.8 watts. In the tune-up procedure, you're supposed to be able to get more than 4.4 watts for that tune-up, and then you're supposed to be able to drop it to, they say 3.8 watts, but of course we're allowed 4 watts, so we jolly well have that. Legality aside, never ever leave these at full whack in what we call service mode. No, because you don't know where without the spectrum analyzer, you don't know where the spurious emissions are going to be, because it's not intended to do that power, and it's not going to last very long on the transmitted transistors. And of course there's no range improvement, is there? You know, we've covered this time and time again, and there's people more experts than me on telling you about decibel differences. I mean, how many we've done radios which have 250 watts, 250 milliwatts output and got 6 miles on them. I did a demonstration on ham radio at various power levels around Scratchy Corner. That was another video which is still in the back catalogue. So on to the transmit, and we want to centralise the peak. So now we've warmed up a bit, it's 3 watts on channel 20. So it's not just the peak but the centre of the peak. So let's see, that drops down, that's the centre of the peak. That's the centre of the peak. These are all about where they should be. That's the centre of the peak, nothing funny there. So onto the transmitter itself. So we need to peak these to maximum really as quickly as possible, because we don't want to damage the transmitter. So it's gone up to 4 watts on the first one, 4 and a tiny bit on the second, and 4.5 on all of them. So once again I'm going to do the peaks. They are interactive to some extent. So we're just over 4.5. So we now need to turn the yellow one clockwise for 4.4. Which is there. And then we need to turn the green one anti-clockwise for our legal limit, which is 4 watts. And bearing in mind this radio is a bit warm, so it may be just over when it's cold, but it's within measuring tolerances, and nobody's going to go to prison for that. So, channel 1, I want this to be within 0.1 of 4 watts. So channel 1 is 4.05, channel 40 isn't transmitting. Right, back to the VCO. Now, why is this totally different? All I can suggest at this stage is that we've got dirt in the trimmer capacitor there. We can change the trimmer capacitor. We can also clean the trimmer capacitor. So we'll go for the that option. I'll go and make my mind up as I walk towards Mr. Chippie's workshop. Okay, so the executive decision was to change the part. I've got the old one out. Well, it's come out in bits, and we'll get a brand new one in. Never used them recovered off anything. They're too easy to be worn at this kind of age. So there is a right way round, and the shadow of which way round to go is clearly shown on the printed circuit board. You end up... Okay, drop that one on the floor. Let's get another 95 pence out. That's another one on the floor. I can see that one. Let's try the round nose pliers. Problem is the wax has seeped as well, and that's not good. Yep, that's in. Put the bottom in on temporarily because of the capacitive effect. Let's put the one screw in, power it back up, go to channel 1, and we'll do that VCO again. So it should be just transmit, and receive should be where it was. I thought you was going to have a real cheapo job then, but no. I'm not looking for parts, I'm not looking for work. I'm not one of those cheap MOT garages. Oh, you need a such and such. Right, transmit. It's just slightly low at 2 now. Let's see what it says on the Marconi test set now I've done that. Wallow. It says it's a bit low. Well, it isn't, so the thing's lying today. So it's now 2.2 to 2.5. I'm going to come back to the transmitter in view of changing that part, and we'll now concentrate on doing the receiver. Then I'll go on my job and come back in a few hours and make sure I'll leave the set on. In fact, I ought to take the chassis with me in the boot of the car so it rattles around, but I'm not going to. Right, receive. Oh, let's do frequency. Do frequency. Put the frequency meter up. 2779091. It's come up a bit as everything's now warmed up to normal temperature. There's the preset, the capacitor. That's the wrong way. That's the right way. At least it's capable of going where we want it. I normally set it slightly high, but it's worked out spot on today. They do drop with age, so that's done. It was near enough to be not noticeable. Right, so let's have a look at this receiver. I mean, it's spot on. I can't see we're going to achieve anything. In fact, we'll probably fix it worse if we find the detectors out. So 100 microvolts on the signal generator, enough volume so we get a meaningful reading on the oscilloscope, and we'll just do the detector. Let's make sure we've got maximum recovered audio. That was absolutely spot on as it was, but I have to check. Right, cyanide. So I don't think we're going to gain anything. You don't get one of the extra circuits on the 220, so theoretically to be less selective, but that doesn't matter. Oh, got to take the squelch off. So we'll put about 4 dB on and we'll go through the front end. Oh, well look at that, we've gained a bit. Let's drop the attenuator. Is this going to be the best receiver of all time? That was spot on. Tiny little bit there. Let's put the signal up to do the IF. No, that's fine. You can actually see that one with the lower models because you haven't got all the wiring you'd have with something like the Rotel 240, the York 863. So there we go, that's tuned as best we can. Let's see. I think we must have gained some. That's hovering around about the 12. It's 0.2. For 10 dB. Change scales. We've got overlap here, so it can be, yeah, it's still 0.2. And for 20 dB, it's 0.39. Let's do the S meter. Turn the volume down. S meter is absolutely bang on. If we were going to adjust it, it's the preset there, but we're not going to adjust it. So that's fixed itself. Squelch. Squelch to full on the radio, and I want it to, I'll put this over to the attenuator so you can see where we are. We're at 30 microvolts, So I want to be able to squelch out 30 microvolts. So we'll adjust the preset. There we go. Now hopefully when I turn this to 100 microvolts it'll open. It does. So the threshold now, we'll turn the signal generator to standby. I pilot it at 0.3 microvolt. It's just opening at 0.3, which is where it was before. So it's 0.3 microvolts, 100 microvolts. So that's sorted that out. That's now sorted out. So we'll come back in a few hours and we'll leave the set on and see whether the VCO is stable. There we go. Okay, so it's now Friday. Did we do this? Started this on Wednesday, I think. Couldn't do anything CB wise on Thursday. So I've had Mr. Chippie check for dry joints. Because the thing about VCO problems, I've changed the trimmer capacitor, but you know, sometimes disturbing the trimmer capacity could be disturbing something else. So I've had Mr. Chippie check for dry joints. These sets don't suffer from dry joints. He's gone through it anyway in the VCO section. So we're now 2 days later. It's 9 o'clock in the morning, and I've got the set back on channel 40. So I've got the multimeter at the ready. Let's see where the VCO is now. So we'll go on to test point 1, which is resistor 4 far end. We've got 4 volts. It's going to transmit. I'm going to stick picture in picture on, and are we on the main meter, so when it transmits we can see that happening. There we go. There we go. And channel 1, 2.15, 2.13 on receive. So I'm satisfied that the VCO is stable. Let's just kind of waggle the set a bit. Yeah, good. So it's not just a matter we've spent 20 minutes fixing it and then say, yep, that's fine. We've spent 20 minutes fixing the VCO problem, then gone over it for dry joints, then it's been on the bench doing nothing for 24 hours, and now we've come back to it cold and it's perfect. So that's great. So we're actually done. There was nothing else to do to the set. I'll just check low power and that's not working, so we'll just... Did I? No, we never did all this. Right. Never did the transmitter statistics, so put that away. Don't know whether to do the Pi Westminster on 4 meters today. Depends whether I finish this by the time the post comes, because I do know there's a box with about 5 sets coming, including another Rotel 220, but a new in a box one. Or newish in a box. Low power. So we've got nothing on transmit. So as often as not, these presets become dirty. So just give it a quick spray of Servicol. Waggle that around a bit. That's fine. It's set up. It's not being jerky or anything. So I think it's just a matter of dirt on the preset. We're at 400 milliwatts, and I'm on channel 20. Let's go back to full power. It's 4.05. I'm not going to turn it down. It will drop when it's in use anyway. As you all know, they drop with heat. Channel 40, it's 4 watts. Channel 1, 4.05. Low power's 400 milliwatts. And on channel 20, our current consumption at full power is now 1.237 amps. So often come in about 1.4, so this one's working more efficiently than quite a lot of them. Don't know what the deviation meter is going to say today. Well, it says 1.5, so we will take that with a pinch of salt. And on the meter, what have we got? It's banging across. We'll just adjust. We will just adjust that to say 4. Are we on low power or something? Here we go. It's a meter intermittent. Yeah, meter's a bit sticky. So it reads just above the 4. This meter is sticking. Right, we will have to dismantle it. See, I'm just about thinking we can put this set to bed and it goes on and on and on. I mean, the sensible part of me says you don't need a meter anyway, and you can tap it, and it's 40 years old and it doesn't matter. If it was my set, it wouldn't matter. While I've got this front off, to whatever level I take the front off, we'll get some spray on those rather stiff potentiometers. So what we've done is to unsolder the decoupling capacitors, then we can withdraw the front sufficient to work on the radio. These brackets aren't easy to put back on. So we're best off just taking these 2 screws out of the side, just to manipulate the meter away from the front chassis member. So I've got to try and determine what it's sticking on. These are sellotaped, other tapes available. These are sellotaped onto the, just together. Whatever tape they used, it's worked well, hasn't it, for 40 years. So it can stick in various points, including the pivot points. So sometimes they stick on the scale, But that's not the case on this one. So if we get a precision screwdriver in there, right, let's power it up. And what we'll do, because I've got the mic disconnected, haven't I? We'll use the signal generator to make the meter move. So it's struggling there. You can see it tried. Right, so we'll put the meter in, which is now there and all screwed in. Let's put the power supply on. Good. Now these controls. So we did need to take the front off for these. We'll just use a spray oil and let that soak in. As I said before, there's an animal grease and it goes stiff over age, just like you get with record players. We could probably speed it up by working it in. What we don't want is any oil tap lubricant on the track. Right. So making sure those capacitors go back in that hole, we can manipulate the front. Back into position, hopefully. Just like that. Put some screws back in. Put that back in this side. We'll just get this put together. Right, so we're all back together. Let's put it on and key up, and now we'll have to recalibrate it because it's a different meter. Receive. 100 microvolts. He's just there. So we'll bang on the 4 there. But remember, this is only going to read, this goes for all this era of radios. It's a relative power meter, so it's reading the power coming out of the transmitter, but it's relative to SWR. So when I put this on the aerial later on for the on-the-air test, I might key up and it says 1, but the radio's still doing 4 watts. I might key up and it bangs across, but the radio's still doing 4 watts. These days, radios are pre-programmed to say whatever. So the bar graphs just say whatever they're pre-programmed to say. You could take the transistors out of the transmitter, it'll still say it's transmitting because it's pre-programmed. It's just a glorified TX light. So it's a bit disingenuous, but it's the way it's gone. I think the Midland 78 is about the only set still available which has got a relative power meter. So we're done. Put the lid on. Shall we have? I tell you what, we'll just have another look at the VCO. Let's go back to channel 40. Four volts on receive. 4.1 on transmit. So I say that's stable. I just don't like it when there's more than one fault and the meter's sticking. So is he transmitting? The capacitor intermittent, is he transmitting? Well, it didn't for us. So was there a dry joint on there? Well, I had Mr. Chippie look at it. So it's all belts and braces. The good news was the transmitter wasn't ruined, and I'm only going to charge him £1 for that meter. Don't think we've got any more now. Until more, you get scrap sets, but you don't get many scrap cybernets. That was a non-UK cybernet set. Right, the other lid. So it's an exceedingly sensitive radio. It's doing a full 4 watt output. You couldn't ask any more. You don't need loads of knobs because loads of knobs don't get you better performance. So people with sets which are basic like this, and we'll look at the SMC Oscar 1. That's a self tapper. Same chassis, it's got the extra filter, but it's still on off volume squelch type of set. I mean, our base station is still a Cybernet 134. It's got the extra 2 filter stages in the receive. So I say to the owner of this, you're highly unlikely to get anything that will ever receive better than this. And seeing as it's doing a full 4 watt output, you're not likely to get anything that transmits better than it either. But if you want other facilities, yeah, buy another set. Don't get rid of this one. That was always the mistake at the time. Where's Fred? Oh, well, he's sold up. He's bought an electric guitar. 6 months later, Fred's trying to get a York 863 for the 35 quid he sold it for. And of course he can't. And if he does, it's going to want service work. It's like some people have got a kind of very, very limited, we've all got very limited budget, but for hobby, and they have to sell one hobby to move on to another, and that's not good. Right, we'll put it on the aerial. I'll be testing his mic during the on the air test. Just make sure his speaker works. It does. So I think the executive decision is this. We're now coming up to 11 o'clock. I'll go and do something else and like edit this video, and if some radios come in the post, we'll get on with one, and if some don't come in the post, we'll get on with that AM Pi Westminster. Right, let's see what shenanigans is on 19. 19, Roger. No Roger. No Rogers. Right, so quite a few things to do to that, but basically was a working set with a Duff preset or two. Thanks for watching.